Good day, grade 7 learners. Today, you will learn another lesson in grade 7 mathematics. Our lesson for today is all about problems involving sets. After listening this lesson, you are expected to solve problems using Venn diagram. A simple way of illustrating set, subset, and set operation is through a Venn diagram. In your previous lessons, you are taught about these concepts. Today, you will be learning more of its uses, but before we proceed to our next lesson, let us describe the set notation given by the shaded region. Let us start. Number 1. The figure shows the elements which belong to set A. The shaded region is simply set A. Number 2. The shaded region are the elements which belong to set B. This is simply set B. Number 3. Elements are common to set A and set B. This is A and B, or A intersection B. Number 4. Elements which belong to set A or set B or to both sets. This is A or B or A union B. Number 5. Elements of U that do not belong to A. This is complement of A or A prime. Number 6. Elements of U that do not belong to B. This is B prime or complement of B. Number 7. Elements which belong to set A but which do not belong to set B. This is the difference of A and B or A minus B. Now, in solving problems using Venn diagrams, we have to be familiarized with the terms or words that can be used in solving problems. We have these 4 terms: union, intersection, difference, and complement. If there is a word or, then the operation to be used is union. For intersection, we have the word and or all 3. For difference, if we read the word but not and only, meaning take away. And for complement, we have the words neither nor, neither, or sometimes we encounter the word but not that's also mean complement. There are many simple real-life problems that could be solved applying the concepts of Venn diagram, but this is impossible if you don't have the idea about the setup of this diagram. Let us explore further How this diagram could solve the many real-life problems. A simple way of illustrating set, subset, and set operation is through Venn diagram. Universal set is represented by a simple plane area bounded by a rectangle, and its subsets are represented by circles. Since Venn diagrams are visual representations of relationships, they are very useful in showing similarities and differences between sets. In fact, set problems can be better solved using Venn diagrams. Try to look at this example. Out of 50 students, 23 joined Mathematics Club and 32 joined English Club. If 8 joined in both Mathematics and English Club, how many have joined the English Club only? How about in Mathematics Club only? How many are neither in Mathematics nor in English Club? Can you figure out the answers to these questions? Don't worry, because this lesson will help you solve many problems involving sets. To understand more about it, let us explore. In solving set problems, it is easier to follow the technique start inside out. This is done by putting the common elements first in the center of two or three overlapping sets. Most of the time, when putting the elements, working backward, starting from the last given data, helps solve set problems easily. Let's apply this technique in answering the problem mentioned earlier. Arrange the given data this way. You can start filling the diagram starting from the center of the two overlapping sets as marked by the arrow. Then work backward starting from the last given data. Let us solve the given problem by applying this technique. Make a Venn diagram. Draw two overlapping circles representing two sets, the Math Club and the English Club, inside the universal set. Now, let us use the technique start inside out. Start filling the sets from the inside out. The last given data is 8 joined in both Mathematics and English Club. Put 8 at the center where the two sets overlap. Next, 32 joined English Club. Subtract 8 from 32. That means you need to write 32 first before 8. That is 32 minus 8 equals 24. Put 24 in English Club only. This completes the 32 students. The next data is 23 joined Mathematics Club. Subtract 8 from 23. 23 minus 8 equals 15. Put 15 in Mathematics Club only. This completes the 23 students. Next data is out of 50 students. Add all the elements of the two sets, 15 plus 8 plus 24 equals 47. Since the total is 47 and not equal to 50, subtract 47 from 50. So 50 minus 47 equals 3. Put 3 outside the two sets but inside the universal set. This completes the 50 students. After filling in the Venn diagram with all the elements, let us answer the questions. For letter A, how many have joined the English club only? The answer is 24 students. For letter B, how about in mathematics club only? The answer is 15 students. And for letter C, how many are neither in mathematics nor in English club? And the answer is 3 students. Now, it is your turn to solve problem involving sets. Try to work on this problem. Teacher Anna was collecting data on her 65 students and found out that 43 have cable TV at home, 31 have internet connectivity, and 18 have both. Illustrate a Venn diagram and answer the questions that follow. A. How many students do not have cable TV at home? B. How many have neither cable TV nor internet at home? C. How many have cable TV but no internet connectivity? To answer this problem, use the technique inside out. Congratulations! You have successfully solved problems involving sets. Please do not forget what you have learned because you can apply them in real life and as you keep on learning mathematics. Have a good day.